Hello there, senior high school students, and welcome to our new lesson. This video is for senior high school general mathematics, and we are now in that's about rational functions, rational equations, and rational inequalities. Here are the objectives for this lesson. So at the end of the session, you're expected to define rational expressions and distinguish rational functions, rational equations, and rational inequalities. Let's review about rational expression. What makes a mathematical expression a rational expression? When you say rational expression, it's written as a ratio of two polynomials. It can be described as a function where either the numerator or the denominator, or even both, have a variable on it. So again, it's a ratio. Second is in the numerator or the denominator or both, and they have a variable on it. Let's identify based on these examples. Example number 1. X squared plus 2x plus 1 all over x plus 3. Is this a rational expression? I'll give you time. And the answer is, it's a big yes. Now what makes it a rational expression? Remember, earlier, a rational expression is a ratio of two polynomials. Second is, there's a variable in both the numerator and denominators. Now let's proceed to another example. How about this? Is this a rational expression? I'll give you time. And the answer is, it's also a yes. Okay, let's continue with the third example. How about this? Is this a rational expression? This is... No, not anymore. Why? Based on our lesson number 1, this is not a polynomial function. The numerator is not polynomial because of the presence of your radical sign. But your denominator is an example of a polynomial. It's a binomial to be exact. But again, the numerator has a radical sign. That makes this example not a rational expression. How about this? Is this a rational expression? Think of it. And the answer is... It's a no. It's not a rational expression. Now this time, why? This is not a rational expression even though the numerator is a polynomial, but the denominator does not qualify to be a polynomial. Why? Because of the negative exponent in the variable. That's based on our lesson number 1 for rational functions. How about this example? Is this a rational expression? The answer is, it's a yes, definitely a yes. So we are done with the review for the rational expression. So let's jump into the highlight of this session. That is rational functions, rational equations, and rational inequalities. Before defining each, let's recall the basic symbols of equalities and inequalities. Let's look at this table. What do you call the symbol? So that's equal sign. Here, that's not equal sign. We have here greater than. Then we have the next one, less than. We have also greater than or equal to. And the last one here is less than or equal to. That is just a review on the different symbols that we will encounter as we progress with our lesson. So let's look at this table comparing the 3 important terms for this lesson. We have a rational function, rational equation, and rational inequality. We are going to compare the 3 based on its definition and example. So let's start with the first one, a rational function. When you say rational function, it follows this form. It's a function in the form of f of x is equal to p of x over q of x, where your p of x and q of x are polynomials, and your q of x is not the zero function. Take note that your q of x must not be equal to 0, or else it will make this one undefined. An example for this is this one. We have f of x is equal to x squared plus 6x plus 8, which is a polynomial, divided by another polynomial, which is x minus 2. Now using this one, you can also rewrite that. Instead of using f of x, we can write it as y is equal to this given. Again, this is a rational function. Now, how about for rational equation? Let's move to the next column. Let's see. Rational equation. It's an equation involving rational expressions. That's why it's very important for us to identify if the given is a rational expression. Again, it's an equation, so it makes use of the equal sign. So let's see one example. We have here this one. We have 5 over x, which is an example of a rational expression, subtracted to another rational expression, 2 over 3x is equal to 2 over 7. So that means this example right here is an example of a rational equation. You see the equal sign, at the same time, the presence of your rational expressions. Are we good with that? So the last one is rational inequality. When you say rational inequality, from the name itself, it makes use of inequality symbol. So it is an inequality involving rational expression. So similar to rational equation, where it involves rational expressions, but in this case, you will see inequality symbols. Let's try to see an example. This one. You have a rational expression greater than or equal to this rational expression. You have 2 over x plus 1 greater than or equal to 3 over x. So this is an example of a rational inequality. So let's try to see the comparison of the 3 main terms. You can pause this part of the video and look at the definition and the examples of the 3 terms. Do you understand? Now to assess that, let me have here some items for us to identify. Identify if the one being flashed on the screen is a rational function, a rational equation, or a rational inequality. Let's start with the first item. Look at this. Is an example of what? I'll give you time. That is an example of rational functions. Very good. Why? Because you have here f of x, and you also have the ratio of your p of x. Here you will have p of x is equal to 1, and this will be your q of x, which is x squared plus 6x plus 5. Now well done. Let's proceed to another example. How about this? Go ahead. This is an example of a rational inequality. Now it's obvious because of the presence of the inequality symbol less than. It involves rational expressions. How about this? Identify. And the answer is, that's an example of a rational equation. Let's continue. How about this? This is an example of a rational equation. Great job. Great. And this last example, identify. This is an example of, well, that's none of the choices. That's none of these. Why? None of these because you have the presence of the radical sign, making the numerator not a polynomial. Lesson of rational functions, which deals with real-life functions. Here are the objectives for this session. At the end of the session, you'll be able to determine rational functions and solve real-life situations involving rational functions. So are you ready? Be prepared with your paper and pen as we explore the world of rational functions. Let's start with a review. Let's recall the concept of least common denominator, or the LCD. Given 1 over 3 added to 3 over 4, how do we get the sum considering that they have different denominators? 3 for the first fraction and 4 for the second fraction. So our next question is, how do we get the LCD? Let's refresh our minds on these steps. First is, we will be listing the multiples of each denominator and identify the lowest common multiple. Now what I'm saying is, we will be starting with creating this table. We will be listing down all the multiples. Again, we will be listing the multiples of each denominator. So here in the first row, that will be times 1, times 2, times 3, times 4. Here, our first column will be for number 3, which is the first denominator, and our second column will be for number 4, that's the second denominator. So let's try to see. Let's focus on the first denominator, that's 3. There. Now let's multiply that one to 1, we'll get 3. Multiply that to 2, we'll get 6. Times 3, we'll get 9. And 3 times 4 will give us a 12. There. Now let's focus this time on the second denominator, that's 4. Let's multiply that to 1, we'll get 4. Times 2, we'll get 8. Times 3, we'll get 12. And times 4, we'll get 16. There. Now, what's the purpose of listing all the multiples of each denominator? We are going to identify the lowest common multiple. And here, that is perfect. That's 12. And that further means that 12 here is the smallest whole number that can be divided by 3 and can also be divided by 4. Do you understand? So the next part is you're going to multiply the given fractions by these numbers. So let's focus on this part. Okay, there. So for the first denominator 3, to get 12, we will multiply 4. So we will use that number and multiply it to the original fraction. So let's do that. Like this. Okay, now for the second fraction, 3 over 4, let's look for that number. It's right here. So we multiplied it to 3. So we'll get that and multiply it to the second fraction like this. Now, I'd like to emphasize, allow me to annotate, If you have 4 over 4, that is equivalent to 1, like this. So on the other side, 3 divided by 3 is also equal to 1. Now let's try to understand before we proceed to the next step. 1/3 right here is multiplied to 1, which means that the value is not changed because it will just give you the same value, which is 1 over 3. So doing this doesn't change the value, but it only changes the form so that you'll have the same denominator and it will be easier for you to add the two fractions. I hope I made that clear. Since we are multiplying fractions, we will multiply the numerators and we will multiply the denominators. So again, that's 4 times 1 and 4 times 3. Here, you'll have 3 and 3, that's 9. We also have 4 and 3. So let's see the next step. That's why you have 4 over 12, and the other one is 9 over 12. Next. So again, that's 4 over 12 added to 9 over 12. I hope you're able to follow. So after that, notice that this time, they now have the same denominator, which is 12. So add 4 and 9, which will give you 13 over 12. There you go. Which is also equivalent to a mixed number, 1 and 1 over 12. We also have the decimal form of that, which is 1.08. Now, what's the meaning of those numbers? Now, it depends on the context of the situation, or it depends on the context of the problem so that we can relate or give meaning to these numbers. So that's a recall for the least common denominator. We will be using that as we solve problems later on. So keep that in mind. So let's proceed now to the main highlight of this lesson. Our topic. Our topic is rational functions. Rational functions follow this form. F of x is equal to P of x over Q of x. We can also write it in this form. So instead of writing f of x, we can write it as y. So that's the output of our function. Y is equal to the quotient or the ratio of P of x and Q of x. Here, P of x and Q of x are polynomial functions. And very important for rational functions that the denominator or Q of x must not be equal to 0. It's not a zero function. If the denominator is 0, then it will be undefined. So that's why it must not be equal to 0. Since we've mentioned that P of x and Q of x are polynomial functions, so let's just have a run-through on the polynomial functions. This would be the form of your polynomial function. So let's try to look at some examples and let's identify if it's a polynomial function or not. How about this? Your answer would be a yes or a no. Is this a polynomial function? Recall your junior high school mathematics. I'll give you time. Identify if this is a polynomial function or not. Go ahead. And the answer is, it's a yes. It's definitely a polynomial function. It follows the form of the polynomial function, and aside from that, let's identify its parts. It has the following. The first one is the exponents. So aside from that, we also have here the exponent for 5x, which is here 1. Then these are the terms, and each term consists of a coefficient, like 5, at the same time, a variable like this, which is x. You also have this one, which is the constant. So these are the parts of your polynomial function. So you have the terms, you have the coefficient and variable per term, you also have a constant, and the exponents arranged in decreasing order. So that's it. Let's proceed to the next example. Identify if this is a polynomial function or not. I'll give you time. And let's reveal. This one is? That's a no. Why? It's because of this one. If the given mathematical expression has a negative exponent in its variable, then that is not considered as a polynomial. It's not a polynomial when you divide it by a variable. So take note of that. How about this? I'll give you time. And the answer is? Still no. That's exactly the same reasoning in the previous example. Since we already have here x in the denominator, the presence of that means that we are dividing it by a variable x. So that makes it not a polynomial function. How about this last example? Square root of x over 5. Yes or no? And the answer is That is not a polynomial function. If you see a radical sign, it means that the given is not a polynomial function. So remember, negative or divided by a variable, or when you see the radical sign, those are the clues that those given are not polynomials. I believe that you are ready. So this topic will introduce you to word problems that involves rational functions. So let's have problem number 1. Allow me to read. Jonathan can finish a job in 3 hours working alone, while Lucas can finish the same job in 5 hours working alone. How long will it take both people to finish that job working together? I'll give you time. You may process and understand the problem. So you may pause this video, read again the problem, and understand. Are we good? Let's continue. Now, based on that problem, I prepared 5 steps as your guide in solving work problems that involves rational functions. So allow me to guide you. So the first one is step 1, that's provide the given. Let's identify the given, at the same time identify or determine what is being asked. Jonathan can finish that for 3 hours alone, while Lucas can do the same job in 5 hours. So that would be our main given. Jonathan for 3 hours and Lucas for 5 hours. What is being asked? How long will it take both people to finish that job working together? So that's for both. That is why we have written here both is equal to x hours. We set the variable x. You can actually use any other variable aside from x, but this time for this example, I'm using the variable x, meaning it's the unknown rate for both people to be working together. Do you understand? Great. Let's proceed to step 2. Let us express the given in terms of rates. So let's start with Jonathan. Jonathan can work alone in 3 hours. So the rate there is 1 work per 3 hours. So let's make use of the fraction, that's 1/3. Let's proceed to Lucas. Same manner, we will have 1 work over 5 hours, which is equivalent to 1/5. And for both, same, we'll have 1 work together, that will be the rate for both. That's x hours. 1 work over x hours. So that's equal to 1/x. So these are now the representations of the given in terms of its rates. Let's continue to step 3. Equate. Since we already have here the information for Jonathan, Lucas, and both expressed in rates, so we are going to add the rate of Jonathan plus the rate of Lucas will give us the rate for both. That's 1/x. I repeat, the rate of Jonathan, 1/3, will be added to the rate of Lucas, 1/5. For both, that will be equal to, again, the sum of the two will give us the rate of both. That's 1/x. That's why we come up with this equation. 1/3 plus 1/5 is equal to 1/x. Step 4, we are going to combine. So we are going to combine by recalling, yes, the one that we've used for the least common denominator earlier. So we're going to list the common multiples right here in this table. So I prepared here 5 rows. Now, by the way, if you already have mastered the multiplication table, then there's no problem if you can immediately write and get the least common denominator. This one is only for those who want to refresh their minds on how to get the least common denominator. So let's now continue. So here we have 3. We are going to multiply that to 1, 2, 3, 4, and 5. So it will give us 3, 6, 9, 12, and 15. Again, we just multiplied 3 to each of the numbers. Let's proceed to the next denominator. That's 5. So times 1, 5, times 2, 10, 15, 20, and 25. There. So let's look for the least common multiple. And here, that's 15. So that means 15 will be our new denominator. What is our next step? We're going to multiply the given by these numbers. Recall that you need to look at the numbers right here on the table. So here. So if you're going to focus on 3, so you need to look at this first column. To get 15, you need to multiply that by 5, right? So meaning here, you're going to multiply that one by 5. Like this. And for the second fraction, 1/5, that will be for the second column. To get 15, we multiply that by 3. So here, you will do the same thing. You will multiply that by 3, like this. After that, we are going to multiply numerators and denominators to get the fraction. So, to get the product of these fractions. So, 5 times 1 will give us a 5. 5 times 3, that's the new denominator, which is 15. Added to 1 times 3 is obviously that's 3. Then 5 times 3 will also give you the new denominator. So let's move it to the left side a little bit to give us more space. Like that. Here, we already have the answer like this. I just copied equals 1 over x. Again, that's 5 over 15, the product of these two fractions, plus the product of these two fractions is 3 over 15. I copied equals 1 over x. After that, we can already get the sum of this. 5 plus 3 will give us 8 over 15. I copied equals 1 over x. That's why we have it here. Now, in this part, we will be using cross multiplication. Let's multiply 8 and x. Cross multiplication. So, if you already have a fraction on the left side of your equation and a single fraction on the right side of your equation, that means you can use cross multiplication. I repeat, I multiplied 8 to x and 15 will be multiplied to 1. There. So that will be our next step. So if you already have that, let's erase. Okay, that's cross multiplication. So 8 times x will give us 8x. And 15 times 1 will give us 15. Okay, we're almost there. We are going to look for the value of x. Since there's still a coefficient beside our variable x, we are going to find a way to eliminate the coefficient. And to do that, let's recall a property of equality. So that will be through the division property of equality, we are going to divide both sides by 8. That's the numerical coefficient of the variable. So that we can cancel that one out and we will be left with our variable, which is x. We are looking for this, right? That's our main objective. That's why we need to cancel 8, but we make sure that we follow the properties of equality. Do you understand? I'll erase that. The answer is now 15 over 8. We can write that in mixed number. That's 1 and 7 over 8. That's also equal to the decimal form 1.875. What's the meaning of this? Let's proceed to step number 5. You are going to express your answer in sentence form to answer the question earlier. So here, the value of 1.875 is the number of hours. So the final answer is, it will take 1.875 hours to finish the job if Jonathan and Lucas will work together. So that's the meaning of that number. It's the working rate for both Jonathan and Lucas. That's 1.875 hours. Are we good? You can always go back to the portion of this video showing step 1, 2, 3, 4, and 5 or review all the steps before we proceed to the next problem. Now, if you're good with that, let's continue and I'll give you time to process this next problem. Problem number 2. It takes 6 hours for Kath to complete a job. If Kath and Dan work together, they can finish the same job in 2 hours. If Dan decides to do the work alone, how long will it take? I want you to pause this video, read the problem again, understand, and write down the given or follow the steps mentioned earlier. I know you can do it. Try. Go ahead and pause the video. Alright, so let's follow the steps introduced in the first problem. After reading the problem, step 1 will be identify the given. Here we have two characters, Kath and Dan. Kath can finish in 6 hours, but the second given is now for both. Kath and Dan working together, they can finish the same job in 2 hours. So we have Kath for 6 hours and both for 2 hours, like this. Now the question is, if Dan decides to do the work alone, how long will it take? So the third one here is Dan. That will now be our unknown, x hours. So that's step 1. Do we have the same answer? If yes, then tap your shoulders and say, great job. Step 2. Rates. We're going to convert the given or express it in terms of rate. Because this problem is work-related problems. That's why we are going to change or express that into rates. So let's have Kath first. 1 work over 6 hours will give us 1 over 6. For both, that will be 2 hours, right? So you have 1 work per 2 hours. So that's equal to 1/2. And Dan is equal to x hours. So that's 1 work over x hours is equal to 1 over x. So far, so good. Let's proceed to step 3. This time, we will equate Be careful. You will still follow this sequence. Since take note, you can just get the result of both here when you add Kath and Dan's work rates. So you have Kath plus Dan will give us both. Not Kath plus both will give us Dan. So be careful with that. So this will be our equation. 1 over 6 plus 1 over x is equal to 1 over 2. Step 4. We are going to combine. So let's move that a little bit in the upper left to give us more space. There, like this. Now, unlike our first problem, this time, it's in a different arrangement. So we need to make sure that in our left side of our equation, we are left with the expression having the variable, which is this one, 1 over x, and the remaining terms must be in the right side. So we need to eliminate 1 over 6 in the left side and have it in the right side. To do that, we will be using subtraction property of equality. So let's subtract 1 over 6 to both sides, like this. Since you already have subtracted 1 over 6 here, that means we can cancel that out because it will give us a 0. We are left with 1 over x on the left side, and we have 1/2 minus 1 over 6 on the right side. I hope you're able to follow. Allow me to erase. The next step, it will look like this. We'll copy equal sign. We have 1 over x is equal to 1/2 minus 1 over 6. Let's make use of that. From here, there. You already have on the right side 1/2 minus 1 over 6. Now, remember, in the review portion where we have the least common denominator, we will do the same thing since they have different denominators. We are going to list down the multiples like this and find the least common multiple here, which is 6. And that will be our new denominator. So we'll copy 1 over x is equal to, and we'll copy the given. We'll copy the given, and we are going to multiply the given by these numbers 1 and 3. 1/2 will be multiplied to 3 over 3 because for this column, to get 6, we multiply that to 3. So for 1/6, you already have that in the first row. So you multiply that to 1, so that's why we have here 1. Let's multiply 1 and 3 and 2 and 3 to get the next fraction. So we'll have 3 over 6 for this part, minus, let's copy that, 1 over 6 for the second fraction. Since they have already the same denominator, we will simply subtract the numerators. 3 minus 1 will give us a 2 over 6. Now here, what I'm doing is, actually you can proceed to the next step, which is cross multiplication. Remember, you have a fraction on the left side and a fraction on the right side. But right now, what I'll be showing is, I will reduce first the fraction 2 over 6, since they have a common factor which is 2. So divide both by 2, you'll get 2 divided by 2, you'll have 1. 6 divided by 2, you'll get 3. So that will be equal to 1 over 3. And since it's already reduced, I can now proceed to the cross multiplication. So I have already here 1 multiplied to 3 and also x multiplied to 1. You can only do this one when you have already one fraction on the left side and a single fraction on the right side. Do not forget about that. So the answer for this is, again, that's x times 1 and 1 times 3. It will give us an x is equal to 3. So you already have found the value of our unknown, which is 3. What do you mean by 3? 3 here is the number of hours. It will take 3 hours to finish the work if Dan chooses to work alone. This is now the work rate of Dan working alone. 3 hours. That's our answer. That's for problem number 2. Do we have the same answer? If yes, then great job. Well, if no, that's not a problem. You can always go back to our steps, review your solutions until you've mastered the topic. Just take your time. And finally, remember this. This is the form of a rational function. It can be written as y or f of x is equal to the ratio of p of x and q of x. And take note, your p of x and your q of x here are both polynomial functions where your q of x is not equal to 0.